And the next problem is the active and reactive power delivered at the receiving end of a short transmission line of impedance Z at an angle psi are respectively given by PR equals to Vs Vr by Z cos psi minus delta minus Vr square by Z cos psi. QR equals to Vs Vr by Z sin psi minus delta minus Vr square by Z sin psi, with Vs and Vr being the magnitude of voltage at the sending and receiving ends, delta the power angle at the power limit condition, that is for maximum PR. A. Leading VAR's QR goes into the load for any values of Vs Vr. B. Leading VAR's QR goes into the load only for Vs equals to Vr. Lagging VAR's QR goes to the load for any value of Vs and Vr. D. Lagging VAR's goes to the load only for Vs equals to Vr. This is the problem given in IES 2001. So for this, the answer is A. Leading VAR's QR goes to the load for any values of Vs and Vr. Solution for this question will be identified as the power flow equation for a short transmission line, that is the receiving end side power equation for short transmission line can be written as Vs Vr magnitudes by Z impedance and cos theta minus delta minus Vr square by Z cos theta. This is receiving end active power. And when we see the receiving end reactive power, that is QR equals to Vs Vr by Z sin theta minus delta minus Vr square by Z sin theta. So here in this place, in place of theta, it is given as psi. Here also, simply in place of theta, it is given as psi only. So for this problem, if we have to calculate the maximum power limit, the maximum receiving end power will be maximum value when theta equals to delta. That means here it is given as psi. So psi equals to delta only, we will get maximum power limit. So when we substitute the value of theta equals to delta equals to psi, PR equals to Vs Vr by Z minus Vr square by Z cos psi, and QR equals to 0 minus Vr square by Z sin psi. That means leading, the reactive power is leading here. So leading VAR reactive power means volt ampere reactive, that is leading VARs goes into the load for any value of Vs and Vr. So this is the answer.